Okay, we're starting section 4D. More functions. We're going to add the words domain and range, some new vocabulary. We're going to talk about discrete and continuous graphs, new vocabulary. So we'll just get right to the discrete and continuous graphs. It's pretty easy. A continuous graph, and when you think of the word continually, it keeps going. A continuous graph is a graph that's unbroken. So an example is right here, this line, from this point to this point, there are no breaks in that graph. It is continuous. However, if you look at this example on the right-hand side, you see an example of a discrete graph, because he has isolated points and unbroken areas on his graph. If we were to look and try to connect this graph, we can't really connect it because there are points in between the 2 points that do not appear to be in our graph. This is called discrete. Now we need to talk about an actual definition of the word function. We've used the word function a lot, but there is actually we have never really defined it. So we're going to define it, and we're going to work with that definition pretty much the rest of your algebra career. So a function is a set of ordered pairs, and we've done ordered pairs to make our graphs. We've done a bunch with ordered pairs. That's fine. Where the first element, the x, the input, has a unique second element, or the output, the y. This word unique is what we're going to focus on here in a few minutes. The set of input elements, in other words, our x values, in all of our ordered pairs, our x values is called the domain. And the y values, the output elements, is called the range. So these are formal math terms that the sooner you learn them, the better. We're going to talk about actually looking at graphs and determining what the domain and the range are just by looking at the graphs. So we've got a couple examples down at the bottom of this page. Let me get down there. We're going to ask ourselves, first of all, are these graphs just continuous or discrete? Well, every single one of these graphs is all broken up. There's nothing here that has perfect lines connecting the points from one end to the other. So all of these are discrete. I think maybe we'll have an example of some continuous ones on the next page. So looking at these discrete graphs, they're asking us to identify the domain and the range, remembering that the domain are the x values of the ordered pairs and the range are the y values of the ordered pairs. So in this first graph, I've listed the ordered pairs so that we can pretty easily see what are your x values. There's one, that's a 0, not a 6. There's 1, and there's 1. So in these 4 discrete points, these 4 unique points, I can say the domain, and I'll write it in real formal math notation. This is called set builder notation, from smallest to greatest. The domain is -4, -2, 0, and +2. These are all the x values, the input values, just listed in this nice, neat little set builder notation. Similarly, I can look at the ranges. I can look at all the y values, these guys. I can come back and I can look at them, and I can make a nice, neat list of the ranges. Again, we always list them from least to greatest. So -2, -1, 0, and 1. So we've identified the domain and the range, and we've identified this as a discrete graph. This second one is also a discrete graph. If we look again at the domains, and I have not listed the points here, if you want to write those in your binder now, that might be helpful to you. But if you were to do that and you were to pick off all the x values, you would get -2, -1, 0, 1, and 2. There are 1, 2, 3, 4, 5 points, so I have 5 domains. And similarly, I can go look at the y values of the ordered pairs, and I can see that they are -1, 0, and 3. Why don't I have 5 ranges like I had 5 domains? Well, it's pretty easy. The ranges repeat. The ranges repeat. So this point and this point both have, that's not right. This point has a y value of -1. These 2 points have y values of 0. We're only going to list that 0 one time in our list. This one's -1, 0. This one's +1, 0. So we've got 1, 0 that we list in our set builder notation for range. Similarly, with 3, this point cuts the y-axis at 3, and this point has an ordered pair with a y value of 3 as well. That's why there's only 3 entries. I'm going to leave this one for you guys to do, and we'll talk about it, and we'll see what you come up with in class. Thanks for watching.